All right, hello everyone. Today we're going to be solving Leet code 888, fair candy swap. Feel free to pause the video here if you'd like to read the problem description, but I'm going to give a brief overview. So we are given two integer arrays, Alice sizes and Bob sizes, and each one of these numbers represents a box of candy, and the number inside represents how many candies are in each box. They want to exchange one box each so that they have an equal number of candy at the end. So let me show you here. So the answer here would be 1 and 2. So that means Alice gives Bob a box with 1 and Bob gives Alice a box with 2. So if Alice gives Bob 1, his sum is already 4. So 4 plus 1 would be 5. She gave away 1. So now her sum would be 2, which is minus 1, which would be 1. So that takes care of this number here. And now this means that Bob gave Alice 2 candies. So if he gives away 2, that means minus 2 here, so this would be a 3, and then she gains 2 here, and this would be a 3, and that would be the answer because they both have the same number of candy. So let's do it with the example here, where Alice has 1, 2, and Bob has 2, 3. We put an A here for Alice, so we know this. So Alice is here, and she has 1, 2 candies, and Bob is here, where he has 2, 3 candies. Now, what do we want to know first? It says we want them to have an equal number of candies. We know that there's not going to be any new candies created, so we can just sum up all the candies and divide that by 2, and we know what each person has to equal at the end. So the sum of Alice would be something like 3, Bob would be 5, and just divide that by 2, so that'd be 8 divided by 2, and that equals 4. So we know at the end, both people have to have exactly 4 candies. So we're going to say target equals 4. And I'm going to erase this. So now that we know this piece of information, now we have to know which candies does Alice have to give and Bob have to give so they both have 4. And this can be written out as an equation. Let me move this down here. So put this here. Perfect. We can say the sum of Alice, which is 3, minus A plus B equals 4. And I'm going to explain what these variables mean. Minus A is because she has to give a candy away, and plus B is the candy she's receiving from Bob, why it's B. And that also has to be equal to the same on the other side. So Bob's total is 5. But instead of minus A, he's giving away B because that's one of his candies, so minus B. Plus A, because that's the candy she's receiving from Alice, has to also equal 4. And what we can do here is just plug in each one of Alice's candies into the A position, find what B is, and see if that is inside of Bob's array. And I'm going to explain how that works here. So let's say we're plugging in numbers one by one. So we'd say 3, and let's try 1 first. Instead of minus A, we're going to say minus 1 plus B equals 4. 3 minus 1 is 2, plus B equals 4. So whatever we do on one side, we do on the other. We want to get the variable alone. So this would cancel each other out and be just 0. We'd have B on this side, and 4 minus 2 is 2. Now that we know that B is 2, if she gives 1 candy, we check, is B, which is 2, inside of Bob's array? It is. So we have an answer, and we just return 1, 2. And actually is a quick optimization we can make because Bob's candy is what we're going to be querying, and that is an array. To query an array, it would take big O of n time. But if we turn Bob's candy into a set, it would take big O of 1 time, and that would just be a bit faster. If that doesn't make sense, you can ignore this part, but you always want to have the most optimized code, so an O of 1 is usually faster than O of n, so we're going to go with that. And I'm going to show you guys how to code this up. So let's open this up here. As you remember, first we want to have the total number of candies each person has, so I'm going to call it A sum. So let A sum equal Alice sizes dot reduce A comma C here A plus C. And we're going to do the same thing for B and just change it up. Instead of A sum, we're going to call this B sum. Instead of Alice sizes, we're going to call this Bob sizes. Not bit, Bob. Perfect. So that would give us the sum of each of their candies. Second, we want to find the target. So let target equal, and that would just be A sum plus B sum divided by 2. Perfect. So that would give us a target, which would be, in this example, would be the 4. Next, since we want to have constant lookup times, we would change Bob sizes, since we know we're going to be querying that, into a set. So we're going to say let B set instead of B sum. We're going to call it B set equal new set, and we're going to put Bob sizes in that. Perfect. So now we have a set that gives us constant lookup times, so we'll be much faster. And what is next in our drawing? Next, we want to have this equation and keep plugging in Alice's candy until we find one that contains the answer will contain in Bob's set. So how do we do that? Since we want to be plugging in each of Alice's candies, we're going to create a for loop to iterate over all of our candies. So we're going to say for let I equal 0. Well, I is less than Alice sizes dot length I plus plus. So this would give us each one of our candies. So first, in this example, it would just be 1 and then 2. We don't want to keep typing on Alice sizes at the I index, so we're going to store it in a variable called candy. So let candy equal Alice sizes at the I index. Perfect. Next, we're going to create a variable called possible, which would be the possible answer, because we're going to run this equation, but it might not always be correct. So we're going to call it possible for now. LE. So let possible equal, and that would be target minus Alice's sum minus candy. And we're doing that because if you remember, Alice's sum is here, which is the 3. We're subtracting the candy, which is going to be the 1 in this case. It would be 1 here, so this is the sum. This is the candy, and we're subtracting that from the target. So 3 minus 1 is the 2, and then we're subtracting that from the target, and that would give us the answer B here. So possible will always be basically that equation. Next, we want to check is if B set, which is the set of Bob's candies, has possible, that means we have the answer. So we would return an array with candy and possible. That is a dot. We want to make sure to do a comma. And we don't have to put anything outside the for loop because it's guaranteed there is at least one answer, so it should never get past this point without throwing an answer and hitting this return statement. And let's try it out and see, did we mess this up? Perfect. And this is actually a pretty optimal solution. It's relatively fast. I believe it's because we use the set. I've tried it with using includes and just querying his array, and it's much slower. It'd be somewhere around here. So make sure to always optimize your code. Sets have constant liquid time. Remember that. And that's it for me today.